Hi, you guys. So, we are going to go ahead and we're going to go through the study guide for this unit. So, I'm going to go ahead and I'm going to open up my program so I can go ahead and write. So, this is to go ahead and to go over genetics with you guys. So, the first part it asks us about genotype and phenotype. So, a couple of things to remember, and this is just a few vocab deals. So when we're talking about genotype, we're talking about the actual genes or the letters, right? And then when we're talking about phenotype, we're talking about how it looks physically. So physical looks. And in this case, right, we have to go ahead and they're asking for both the letters and what it's going to look like. Right, so it says attached earlobes are completely dominant to free earlobes. So if it is completely dominant, right, that means that you either have attached earlobes or free earlobes. So completely dominant means one or the other. Right, so I can pick my letters. So if I want to pick a capital E that is attached, and then a lowercase e would be free, right? And the reason why I know that lowercase is free earlobes is because the attached earlobes are dominant too. So that means the attached ones are the ones that are going to show. Okay, the next one, it says red flowers are incompletely dominant to blue flowers. So incompletely dominant means that we have a mixing, right? So this is where we have the mixing. This is where we usually see some sort of blending happening or a spectrum. So in this case, right, we have red to blue, right? So we're going to have our capital R, which is going to be red. Then we have big R, little r, which is going to be purple. And then little r, which is going to be blue. Whoa. And the reason why I know this, right, is that in something that is incompletely dominant, since I have this spectrum, I will see that I have that purple that happens in the middle between red and blue, right? And I'm not using two letters because it is incompletely dominant. Okay, so the next one, we're talking about codominant. So when we're talking about codominant, that means that I see both at the same time. Very commonly, I get my spotting and all of that in there. So spotting usually happens in that sort of deal. Okay, so I said I have brown color hide dominant to white color hide. So again, I got to pick whichever letters I want, right? So I'll have capital B, be brown. And then I'll have capital B, W means brown and white, so brown plus white. And then I'm going to have WW mean white. And you have to remember in codominant, right, in addition to spotting, I'm also going to have two capital letters, right? So I have the capital B's and the capital W's. So that's when you guys will see two capital letters. All right, the next one, we talk about X-linked, right? So we have to go ahead and write some possible male and female genotypes and phenotypes. Okay, so I'm going to zoom in a little so I can write in a few more. So in X-linked, we have females that are XX, right, and males that are XY. So there are different types of female ones that we can get, right? So this one, we have AA. So this means that we can see color. So this one we're going to write color vision, right? A, little a, right? This one is also color vision. And the reason why it still is color vision is because a color vision is dominant, right? If you do not have color vision, then you are recessive, right? So little a means that you do not have that color vision. So it means that you are colorblind. Right? So those are 3 possible females. For males, there's only 2 possible. We have XY. So these are our males. My males, again, right, the letters that we have here, right, they can only go on the X chromosome, right? So my males, I have XA or X little a, right? And this one is going to be color vision. And this one is going to be colorblind. Okay, so let's go ahead and let's get into some of these practice problems. So it says, Sophia, whose blood clots normally, has a hemophiliac, which is a recessive sex-linked trait, father. Her husband's Tommy's blood clots normally. Their first child was a girl, and their second child was a boy. Okay, so now we have to go ahead and, using that information, determine the genotype and phenotype, right? So Sophia's blood clots normally. So that means that, first of all, she's XX, right? And very similar to kind of what we have up here, we have to go ahead and we have to look at these different options, right? So Sophia, since she is since she does not have hemophilia, she has at least one dominant letter, right? But we go ahead and we look over here and we see that her dad is a hemophiliac. So if her dad's a hemophiliac, then the only way that she was a girl is that if her dad passed down one of those X chromosomes with that hemophiliac allele, right? So Tommy, right, we have an X and a Y, right, because he's male, and his blood clots normally. So since he is normal, we're going to have that A, right, because A means that it clots normally, is normal, and little a is hemophilia. Okay, and now they're going ahead and they're asking us what is their genotypes for their daughter, their son, and their chances of their third child that will be a girl and a carrier for hemophilia. So we have to go ahead and we have to get in here and fill out this. So I'm going to go ahead and I'm going to fill this out quickly. Okay, so, oh shoot, that's wrong, my bad. Let me just double check. Looks good. Okay, so it says, what are the possible genotypes for their daughter? So I'm going to go ahead and I'm going to look at the females, right? And I'm going to go ahead and write in that I have one female that is this, and I have another female that is this one right here. Whoa, that's messy. Okay, so if I look at this, I have a homozygous dominant female and I have a heterozygous female, which is also called a carrier. So, and then they ask what are the possible genotypes for their son. So I go ahead and I look at my Punnett square and I write that, right? And then it says, what are the chances that their third child will be a girl that is also a carrier for hemophilia, right? So I have to go ahead and I have to look at all of this, right? And I'm looking at the whole Punnett square this time, right? Because that's what they're asking for. And I have to make sure that I look at a girl. So immediately I'm 1 at 2, right? And a carrier. So I only have one girl right here that's a carrier. So in this case, right, it'll be 25% chance. Okay, so that is it for now, and I'm going to go ahead and go through the next couple questions in a sec.